Today we're going to do kind of the reverse of what we did yesterday. Yesterday we took a function and we sketched this graph. Today we're going to start with the graph and see if we can work backwards to find a possible function. So if you think about what we did in the previous lesson, some of the things we found from the graph were the zeros, were the x-intercepts, and we also had to look at the exponents on the zeros to determine whether a function turned or crossed at a particular zero. The y-intercept, so that's p of 0 we had to find. And then we also looked at the end behavior. So we're going to look at these same things and work backwards to find a function. Now a polynomial function has a general look to it. We might have some kind of a constant and then various factors. Maybe this is even, maybe this is odd. Those are the things we have to find. And my constant could also be positive or negative. The end behavior is going to determine that. The y-intercept is actually going to determine the value of k. These guys, we're going to choose the lowest possible exponent, so they will probably either be 1 or 2. If it's even, remember, if it's even, it's going to turn. If it's odd, it's going to cross. And then these are going to be our roots. So we're going to start by looking at an example. Alright, so here's the graph of a polynomial function, and we want to try to find a possible function for this graph. So what we do, we're going to kind of work backwards. We need to look at the end behavior to determine whether my final exponent is going to be even or odd. So that's going to help us figure out whether we have double roots or single roots when we do this. So if I look at this end behavior, they're pointing in opposite directions. That tells me my overall largest degree is going to be odd. If they were pointing in the same direction, it would be even. Think of the cubic function or the squared function as kind of your guidelines for that. So once we have that, then we're going to find the factors by using the zeros. So if we look at my graph, the graph or the function crosses the x-axis at -1 and +3. So I have x is equal to -1, which makes x plus 1 a factor, and x is equal to 3, so x minus 3 is a factor. If I start to build my function, p of x is equal to some constant k, x plus 1, x minus 3, but we have to look. This guy turns, so that means he's got to have an even root. So I'm going to make him squared, and we said our overall exponent had to be odd. Well, if I square this guy and multiply him by him, he's going to be odd. So that should be sufficient as far as whether we have a double root or a triple root or whatever. And then the last thing we look at is to find the k value, we look at the y-intercept. So in this example, p sub 0 is -3. That means -3 is going to be over here when everything else, when my x values are 0. So this is k times 1 times -3 squared. -3 squared is 9, and you would divide that, and k ends up being -1/3. So my final answer is going to be p of x is -1/3 x plus 1 times x minus 3 quantity squared. That is a possible function to match that graph. Alright, the other type of example we have is when I don't even give you a graph, but you're just given some descriptive information about the function. So here we have p of x is 4th degree. So I should have 4 factors, or I should, when I multiply my leading terms, I should have an exponent of 4. It has a double 0 at x equals -2. And then I'm given this, p of -5 is 0, p of 4 is 0, and then p of 0 is -160. So this right here is the y-intercept. The other two are going to be zeros of the function. They are x-intercepts. So we can still find everything that we need. I have a root here. So if I start with x equals -2 and I work backwards, I know I have a factor of x plus 2. And then for my other roots, I can put them in as x equals -5, so x plus 5 is going to be a factor. And the same thing with 4, x minus 4 is going to be a factor. So I have 3 factors and one of them is double. If I'm going to start to put this thing together, I have p of x is equal to k times x plus 2. We said that was a double root, times x plus 5 and x minus 4. So if we double check, we have 1, 2, 3, 4. It's a 4th degree, so I have all my roots represented. We don't really look at the end behavior in this problem because there's nothing to really use, but my last thing is the fact that -160 is the value I get when x is 0. So when x is 0, my first factor becomes 2 squared, my second one becomes 5, and my third one becomes -4. When I multiply all that together, this is 4 times -4 times 5. That ends up being 80, negative 80, so -160 is equal to -80k, and k ends up being positive 2. So putting all this together, my final function, p of x, is equal to 2 times x plus 2 squared times x plus 5 times x minus 4. So that's another way to find a function from information that you're given. And we're going to practice both of these things when we get back together in class.